sum of a geometric series, I go to my formula sheet, and I write out my formula. I want to find the sum. So this is what I want to find. So in order to find it, I need to know everything on the other side. Okay? Do I know term 1? Let's do a list. Do I know term 1? Yes. Term 1 is negative 3. Do I know r? Yes. What am I multiplying by? 5. Because it goes negative 3, then negative 15, then negative 75. Do I know n? No. This is a problem. Okay? We cannot use this formula unless we know everything except what we want to find. So I wanted to find the Sn, that's why I put a green box around it. So this is okay if I don't know this. But I would need to know everything on the right part of the formula in order to solve it. And I know term 1 and I know r, but I have a problem because I don't know n. Now if you have that problem, it's giving you a hint what you need to do first. We need to find n first. Well, how do we do that? We have to look at the other formulas. This is geometric. We have another formula for geometric sequences. We have a formula that says term n equals term 1 r to the n minus 1. And we would need to find out how many terms there are. If we wanted to do this, we still know term 1. Term 1 is still negative 3. We still know r. R is 5. Do we know term n, which is the last term? Yes. We know that term n is negative 46,875. So using this formula, we could plug in everything except for the n that we want to solve for. So let's start. Let's see where that goes. So I plug in term n is negative 46,875. Term 1 is negative 3. R is 5 to the n minus 1. The strategy for these ones is we're going to get this power where the n is by itself. So I'm going to divide both sides by negative 3. And I get 15,625 equals 5 to the n minus 1. And at this point, we know that n has to be a nice number. You haven't learned logarithms from grade 12 yet, so there's no way that we can do this other than educated guessing and checking. 5 to the power of 4 is not nearly big enough to be 15,000. I have to try a bigger number. Maybe you jump up too high. Oh, I did 5 to the 7. It's too big. There's not too much more guessing I have to do between 4 and 7. Trust me, you will find this pretty quickly. 5 and 6. There it is. So I can rewrite 15,625 as 5 to the 6. Since n has to be a nice natural number, it's not hard to guess and check to figure it out. In grade 12, we solve these questions when it's not a nice number, and then you will learn how to use logarithms to figure that out. But for now, it turns out to a nice number, and now we have some very difficult math to figure out. If 5 to the 6 is 5 to the n minus 1, you have to figure out what n is. And by the smiles, I see that you realize it must be 7. 7 minus 1 definitely is 6. If only math was that easy all semester. And now, okay, we found n. Now we have everything, right? I'll write out the sum formula again. This is what I want to find. And now that I know that n is 7, I can find everything. I want to find S7. I knew that term 1 was minus 3. 1 minus, I know that R was 5. And now n is 7. I can type this whole thing right into my calculator all at once. Negative 58,593. So just to recap and look at this whole thing that we've done so far. That's not what I wanted to hit. We wanted to find the sum, so it's going to be natural for you to write out your sum formula. And if you're wanting to find your sum formula, right, I put a green box over what I wanted to find. That means I have to plug in everything else. So I needed term 1, I made a list. Okay, I know term 1 is negative 3. I had to do a little bit of math, and I found out R is 5. But then I ran into a problem. I have no n. So now I have to take a step back, and I need to find n first. And to find n, I don't have to use my sum formula. Sometimes you could use your sum formula, but in this case, we have to use our term formula for a geometric sequence. So I went to my term formula, I wrote it out, I put a little green box as I wanted to find the n, and for this one, I listed, do I know everything? And here's a place that sometimes is tricky for students. Because they don't know n, they think they don't know Tn. Because how could you know Tn if you don't know n? Okay? Seems counterintuitive. It seems like maybe you shouldn't know Tn if you don't know n. But we have to realize that Tn, that's any term. And if we want to know what the very last term is, that's going to be the one where we have n terms. Tn often represents the last term. So I know what the last term is, and if I solve what n is for that last term, I will know how many terms there were. So even though you do not know n, we do, in this case, know what the last term is. So we can put a number in for Tn. Now we could solve for n. We did that. And then we realized, well, I've solved for n, but I still need to find the sum. So now I need to go back to my main formula. I can now plug in everything, and I can find my sum. So, take 5 minutes, try question number 9.